to office tomorrow for something. So that's been like that for this week. I want to share for I don't know. Give a short pause. All right, let me show this. Hi. All right, let me just drag and see. Oh, right, just give me a minute. Let me send to my phone. Then I'll copy. I don't know why it's like that. I guess probably because we have larger number of people that are not within my organization. That is why it's not easy to share. I'll just go into my phone and share now. All right, we have someone at the lobby. It's nobody there. Oh, no, I'm not in meeting. It's not in download. I'll be sharing with us on our WhatsApp. Let me see if that works. I want to be sure there's nothing missing. There should be one employee data. Please, I hope you can start see it on the WhatsApp group now. I'm sending them the. Yes, sir. Um, All right, so let's start with what I've shared. There's someone on the lobby. Abdulaziz, can you stop your live video, your cartoon video, so it will help us to have good network. So let me share my screen. It has been a long week that we've started this training, and I hope to be ending the training today. So what we do basically today is that we are going to be using real life data and see that it's still just almost the same like what we've been doing before. So um I have people trying to join. The first data we'll be using, I think I have them on my download, is let's start with the most complex one because of our time. Like I said earlier on the group, that I almost thought this class will not hold today. Let's start with the complex one, which is a very dirty data. I think I named it one name, dirty data or something. All right, this is the name. I named it dirty data. And I think you have this data on your WhatsApp already. Please confirm.
Yes.
All right, so yes, sir. This is what we'll be working with. It's just an organization sales data. It's an organization sales data, and would just try to analyze the data and see what we can get out of it at the end. Like I mentioned, it's similar to what we've been doing, but it's always good for you to have real experience, and that's why I try as much as I can to find the dirty data. That let's see how we can clean the data up, and let's also see what we can get out of the data. So I could start from this page that we have here, but usually sometimes I prefer to start on a very um, blank page, so we can have the full knowledge of what we are doing, which is just what I'll be doing now. On new notebook drive. Yeah, please confirm you can see my screen.
Very well. Very well.
All right. So the first thing is, we come to this folder here. On this folder, the next thing is, let's go to the directory where we have our file, dirty sales data. So I'll just drag it here or hit OK. So I have that there now. So the next thing is to import my pandas as PD, right? And maybe we need Matplotlib. Matplotlib dot plots as plot, right? Am I right? In this class now, all of us we should be on the same page. If I'm wrong, you should be able to tell me that I'm wrong. If I'm right, you should be able to tell me that I'm right. Is this correct? So what's wrong here? Someone should guide us.
Import.
Good. I think this should be PLT2. What's the error we are getting here? Someone should guide us. I know what is missing already, but I just want somebody to say it.
Pi plot. PY.
PY, pi plots.
PLOT.
Yeah, as plots. All right, so we've import our major libraries that we'll be needing basically. So I move to the next page here. Sorry, this is just one at design. Right, let me press Control Enter, Shift Enter to the next page. All right, so the next thing we'll be doing now is to import our data in. You know what we've been doing before now is that we just use our NumPy framework to generate data, and we continue to analyze. And people have been saying, can we import real life data, um but like I've mentioned, is it's actually just the same. It's the same, and that's what we will be going through shortly now. So the next thing is we do df equals read, df equals read um underscore csv csv. um Sorry, we need the pandas framework here. Please, if you are just entering, you can mute yourself. And let me see if you have anybody at the lobby. You don't have anybody. Underscore CSV. This place now, we just open a single column here, slash. This is the data set we want to import. I can come here and just copy the parts and put it here. So we have the data set. Let's run it. Usually, when you have this data set like this, you don't just continue to analyze the data. You know, I talked about data mining, data bundling, and all that. We need to understand, have the full grasp of what our data is really all about, and also see what is it that we can actually generate from the data. So the first thing is, let's check what our data looks like. So this shows us overview of our data, which is df.ed. You realize Paul used all these things when he was taking us through this, and I kept saying it that they are applicable continuously. As a matter of fact, if for example, you are given an interview work to do, probably to do on pandas, you don't skip all this stage and start analyzing. I remember I did one interview like that. The data set they gave me was a very clean data set. Very clean data sets. When I mean clean data set, the data set is clean. But yet, I still go through all this process one by one. And when I'm done, I now state that data set looks very clean, then we can proceed with analysis. You understand? So let's check like this. For here, we know that we have transaction ID, we have customer ID, we have transaction date, all and all like that. So now let's continue with our data cleaning process. The next thing is we can just do df. Our data, this thing is df dot none. Will that give me what I need? Sum in front. So we want to see if we can check if we have um how will we put it now? If there is non-value within our data, I think we need to add print here. We are printing this function. What you are basically telling pandas to do is that check these old data sets that we have, right? Check anywhere we have none, sum them together. Check anywhere we have none, sum them together. So let's check. What is happening in here? df is non print where df is non I have it as df. So what is it about the error here? Print sum. Let me get the error message. It has no non-attribute. And even at that, it should give me the overview now. And I'm very sure this data should have a non-value. Let me check the data. Yeah, look at the non here. So what is it saying? All these ones are non-value. That's what I imported.
Hello,
So
sir.
yeah,
Um, Based on that attribute error, I clicked on the explain error. So the explanation I was giving them is that is null, not just dot null. Dot is null.
okay, is none. All right, let's go back to our here. It should be is none. Don't mind me. Sometimes things like that can happen. That's why you practice, you keep on practice to avoid. All right, so this one is telling us that in transaction ID, there is no way we have no value. In customer ID, we have 3 columns, we have no value. In dates, 81 columns with no value. Amount, no non-value. This no non-value. Now, somebody will say that, how do we solve this problem? Someone will just say, we should just remove all non-value. It is wrong. See, if you remove just all non-value, then 88 customers will be missing. Whereas where we have non-value basically is just 3 customers. So easily we can remove the non-value for these 3 customers and we'll be fine with this data set. And for the rest, this is Python. We may just try to interpolate and see how we can manage things. For example, for this category, we can fill it with common category in okay, for category, we can say that anywhere we have no, it should say on no. You understand? Like, okay, we don't know the category that it belongs to. Yeah. So with this, we are not using 188 data. For transaction date, we are going to be using a function that could just solve that for us. Probably you should just pick the nearest date or maybe the common dates. These are some of the things we'll be doing. Why for the um customer ID, obviously there's no need for us to check to keep this because no customer has that record. We can easily just remove that. And I think we would be safe. So all these manipulations are what we'll be doing. And we would also, that's more reason why it's good to have real life data. to help us see the real life scenario of what we can be seeing. So the first thing is we want to remove, there are some of our sales value could possibly be showing as let's say negative or something. So in that case, we want it to say that whenever we say our sales error as negative, we know obviously is an error. So we would just be saying that it should return it as none. And there is a function for us to do that. It's still pandas. So we can say sales underscore data, open your brackets, and then pick this column name. What's the column name? Sales amount. Sales amount. And then say equals to PD PD dot to numeric. What this is simply saying that, do we have a data set? Okay, sorry, our table is DF, so it shouldn't be sales data. It's DF. It's DF, right? I'm right now. Okay, it's DF. So that's why we're having that error here. So this column now, we are just more like working on the column. Okay, this column should now be equals to this. That's anywhere we have it as any situation in our column that we have it as let's say an invalid value, for example, where we have NA, where we have it as negative, what should this thing do is that you should just simply return them back as NA so that we can drop them eventually. Would also then move on to remove the place where we have our customers data as non-value here. But before then, let us fill up our sales table. Sorry, our category. DF category here. We now say fill NA, open brackets, unknown. Anywhere we have NA in our data, like there is no value in this column, fill it as unknown. Right? And we then use a function called in place. True. What does this in place true does for you? It's just that these changes you've made should continue in your data sets as you proceed. Just more like you made a permanent change on it that should just be like that throughout your data set as we continue the analysis. So you can read more about in place true equals to truth. It's something that we use very well. Like probably you are reassigning this column with this value you have in here. So it's commonly used very well. It's commonly used in when, most especially when you are cleaning up data like this. So what this is saying is that where we have unknown, where we have error in our category should show as unknown. Do we have anything like that here? Let's run from here again and see. Let's run. Let's run. Let's say we want to see 20. Yeah, probably we can see any unknown. You can see all these ones now, they are NA here. All right. Let us continue. We check our non-value. We apply this function and we want to now confirm this. Let's check our head again. Usually this is the usual practice. Once you make changes like this, we try to see if there is any effect on it. Category. Okay, you can see unknown here now. It's actually based on the function. If we can use another thing if we don't want to use unknown, but anything you put there is what happens. It will just go on and on to see wherever you have error in your column and replace it with what you have in there. So obviously, in place truth is basically saying that, okay, whatever conditions we have here, whatever thing that we are carrying out here should automatically replace this column permanently as we move on. All right, so the next thing is we want to remove missing value from our hello. Hello, everybody. Please confirm I'm back. I just received the call.
Yes, you're back.
Thank you. All right. So what we wanted to do now is we are at the point of this cleaning, still cleaning of our data. So I will just let me just make this. Let me continue from here. So the next thing we also want to do now is that payment method. Payment method. There are some missing value in our payment method also. So what we'll do here is we'll just be looking at it like instead of just using n unknown, we want to use a function that will in our payment method just fill in the most common one for the payment method. Like we didn't capture the payment method of this customer. You know, most of the time these things happens. All right. So most of the time, this thing happens in organization probably before they employ an analyst. You know, there are some people in organization, they believe they are analysts even though they are not. They'll keep on capturing data in any way, any form, even though it may take you time to orientate them that what they are doing is wrong. So they may probably in this organization, they will not be capturing things the way they ought to. They have missing payment method. So what we'll be doing is that we will just replace it with the most common one. Let's say the most common one that the customers are using. So let's go on. We say DF, pick our payment method column. Now we then say if dot fill NA anywhere we have missing value, anywhere we have missing value there, open brackets. We now want to put, you can easily put unknown here and it will take unknown, but we'll be using a function to say, to pick the most common value, the most common missing method. And you'll see what we'll be using is just the normal statistics that we are using before. Sales underscores data. So sales, all right, so what we have here is our DF, yeah, payment method. Let's speak it, the payment method dot mode. Mode in our statistics, you know, it's what is just the most common, sorry, it's just the most common the most common thing in our data sets. So you close the brackets and you add this in front here like this. And once you are done with that, you also need to use your in place equals true. In place equals true basically says that convert whatever you have here, let it be stored on this column that you are working on. You know, in this place, I use equals to here, and this one works well, it replaces it. But if you realize this category here, I didn't not use equals to. I just write the column, write all this, and just put in place true. So just replace it for me. That is that. That is that for that. So let's run this and see. Fine. It works well. So we've replaced that with the most common payment method. Any customer that doesn't have a payment method now would be using the most common payment method that we have here. I think this should be here and should be outside. Do you have anybody with question? All right, so let's continue. The next thing we would be doing now is that we would be going to our customer table, and basically what we'll be doing there is that we will be removing any missing value. Any customer that is not found, probably is empty, none or whatever, just remove the customer. So we'll remove the entire row. The entire row will be removed entirely. So that's what we want to do now. And to do that, we use df dot drop NA, bracket open, subsets. You can see this thing has already bring it up for us. Subset is equals to, we pick our customer column, which is customer ID. Sorry, it will be this here. Customer underscore ID, comma, in place true. So you can see that it's straightforward. This data frame, drop NA anywhere we find it in our customer table. So just like we are delete every rows. That is why when we got here, I said it will not be too logical. It will not be logical for us to say we want to remove this, we'll be losing almost all the data sets that we have. So that is why we did not tamper with this. But for this customer table, we could remove it. In natural sense, we don't want to have record for customers that we cannot trace. And so far for this kind of analysis, it's straightforward. What else do we need to do? We would also be trying to check for anywhere we have duplicates. Anywhere we have duplicates here. I think this should work here also. If we come here, all right, so sorry, everybody, are you following? Hello, are we following?
Yes.
Yes, sir.
All right, thank you. So this should work. We can this work here. I think I've done something like this before. Print df. df duplicated sum. All right, so we can check our data set. All right, so in this old data set now, it's like we are having like 30 columns that are duplicated. Do you know how this confirms for us? Everything within the rows, like customer ID, date, everything that you have here, they are just the same, nothing changed at all. You understand? So this is what Python will regard as duplicate. That is why you need to be very careful. In your own organization, it will be allowed that customer may perform transactions more than once. You understand? And the duplicate value is not an issue for them. So it will be now wrong for you to now say, Mr. Sam said we should remove duplicates. I want to remove the duplicates. You understand? That's why I took you here to explain the concept before I just move on. But most of the time, it's very rare we have that kind of data sets in most cases. So Python gives you avenue to just remove it. And that's what we are going to be doing now. So we just say df dot drop duplicates. You can see drop duplicates that you have here and run it. So once we are done with this, we can just do df dot add. Let's see the first 10 column and see what we have. I think the data looks somehow more tidy, but we are having some NA in our transaction table column. So how do we go about that? I suggest we just use the most common, like we did for this, the most common dates. The most common date. Or what do you suggest? Do you have anybody that want us to use something else? Can we go with this? Hello, I want to be sure we are together.
Yes, sir.
All right. So let's go with this. Here we just come here and use transaction. Let me just copy it. Transaction date. Transaction date. Dot mode. Should we use, let's use media. Let's use media instead of mode. Right. Do we have any error in here? Okay. What's the error we are getting? Okay, I think he just want us to actually convert this to a table. I think Paul mentioned this for us. Most of the time, Pandas doesn't take a column as a table column. Most of the time, like Python, it doesn't take column as a table column directly. But especially probably when you are importing from CSV or from any other data source. So you want us to be sure to convert that to a table. Where is our code now? All right. So let's come back here. Let's get this. Usually, I hate to see this kind of things. So let's do this. So the first thing we have here is we are actually converting. I think there is something we can do to check our data sets. Why not let's use that? Our data type. Someone should give me that code. Paul taught us df dot type. Right. Am I right? Dot type. Let's see. It's wrong. I actually want to check our data type. Can anyone borrow us that code?
Me, I'm even lost.
Now, what we are saying here is that transaction table, we have missing value. We want to just say that, okay, use median dates for us here. And we use it, it works actually. But Pandas is saying that that column is not a table, it is not in dates as it were. So it's bringing that error. So before I convert it to dates, I want us to just check it ourselves, the state, the data type for that transaction date, which is this. Now, this one actually part of our data cleaning process is that we ought to have checked all these things one by one and see anywhere where we feel there is need for adjustment or whatsoever. As you can see now, our date column data type is what? Objects. And he's not saying it as there. So that is why he's not accepting what we did there. He's not accepting it. So we need to come here and say this. Convert date column to date, which is what we are seeing here. Convert it to a date data type. Paul taught us this. And after converting, in place and use our median. So use the median dates. Look at the old date and find the median, the middle date at the middle or something in the old data set as the date missing there. So with this, we have it done. We have it done. Yeah, let's come up again. See where we started from. We import our pandas. We import our table. We just try to look at it here, like, okay, let's see what we have. We can see NA in our table here. We are going to run this same code again and see what we've been able to achieve. In our category, you can see NA here, all that. So we need to remove all those things as much as possible. Now we check none. We discover that we have none in all these places here. And we also move down. We started removing all those conditions for our sales table. Our sales table looks correct, right? But in anywhere we have we first of all convert to numeric here, which is what we did for our sales table. And if you come down here, and we are saying that anywhere there's anything like error here, it should replace with 0 or something there. So let's come back to this place now. This thing, you can see it is in floats, sales amount. If we had not done that, it will be in the same object with all these ones. Okay, so we have done that here, and we move on again. We started removing anywhere we have NA. Use the mode, the most common one for our payment method. We come down here, drop anywhere you don't see customer ID, drop the entire row. We come down here, we also say that, okay, drop any duplicate value in our data set, and we have it here. So we run this. Let's go that. Our date as NAO. How do we solve the problem? So that's where we moved on here. Firstly, what we did here was to convert these dates to dates in actual sense. And after converting it to dates, we now say that anywhere we have mean value for, anywhere we have non-value for our dates, just use the median dates from the old data set. Look at the old data set, get the median of our date and use it for us. So that is what we have done so far. Yeah, so let's move on again, and let's run that our data set again and see what we've been able to achieve. Can you see our date column is filled up? Category, we can see unknown. Payment method, what is happening with our payment method? Yeah, I think we have run a code for that before for our payment method. He said you should use mode. Oh, I didn't run it again here. I just wrote the code. I did not run it. So let's come down here now. Let's run. Now we'll be using the most common payment method. You can see that payment method also is filled up. There is no any blank value here. Some people are confused. Any question? If you
Yes.
are, all right, Aziz.
Yeah, so from where we started removing the duplicate, it said we should print df.duplicated. Then you said some. That's where things started
See,
getting
this
complicated.
function is this. Look at this function. Is that df is our data set. In this old data set, where do we have non-value? This sum is just like an aggregate function. You should now sum this value for us for each of the column. That's where this comes in. This sum comes in. What this one will do for you is that it's just looking at the old data set. Where do we have none? But with this sum, is now for each of the data sets, sum it up for me. It's like the aggregate function. And that's what you are seeing here. For each of the column, rather. And that's what brings this for us. Can we run it without sum? I don't think I've tried it before. Let's run it without sum. You can see false, true, false, true. All these ones are false, 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 false. There are no non-value here. But there are some places that you see true, that we have non-value because it's not showing us the old data set. It's just showing us the falses. Sure, you understand. So what sum basically does for us is to just look at the data set and do it for us instead of we counting it one by one. Do you know why we're having 0, 0, 0, 0 like this now? Assist. Hello, I
Yes.
need a response.
Yeah.
Why? Why? Can you give me the reason? Please just say something. You ask the question. Say something, unless if you are wrong, we can correct you so we can move on.
So this one is saying zero, that we don't have any null value for all the fields.
Okay, because we have cleaned it up to this point. So the df that you have here is the one stored on the brain of the Python. You understand? And that's why it's giving you this. If we run from beginning now, we run this from beginning, we will run the df, we will run this, we come here, now run this. You can see that we have it here. So usually after cleaning your data sets, you should rerun this thing to be sure of what you have done. So we have done this here, we run it, run this, we run it, run this also, drop any form of duplicate across board based on the customer ID. We try to check our data set. We discover that our date data set is not in date. We run this here. We run this after we convert it to date and we fill it up with the mean here. We move on to just check our whole data set. So the next thing we can do here is this. The next thing you can do here now is let's check our non-value again. We can see that is correct. And another thing we can also be doing again is let's check our df dot d types to check our data type again and be sure. So we are sure that okay, this is in date and time, and our sales is in floats. Are we good? So the next thing we can be doing now is we can be playing around with this data and be seeing some things. For example, can we look at sales by category? We want to check for sales by category. There is what we want to do now. So let's have something like, okay, sales by category equals to df dot group by category, group by the column you want it to group by, the column you want to sum up, and put the function in front here, sum. So you can see, let's run this. So what we can then do now is print sales by category, which is the variable we've declared up here. Can you see? So by category, this is the sales. Remember the non-column that will non-value category that's category that we are doing the what's it called, the non that we created in our cat that we have done before. You can see it here. So the total amount of sales that falls in is this. Any question? You can remember now. Let's do our f function. Oh, will this work? And yeah, oh my, that is not working. I want to just, okay. You can see it's showing here actually, but I want to just put it in front here, like to show Naira here. But however, it's fine. Let's continue with our analysis. Let's continue with our analysis. All right, so what next can we then be doing here? We can be looking at a situation whereby we'll be looking at sales per month, sales per month. And how do we go about that? That is what we'll be doing now. We want to look at sales per month. And to do that, we are going to be using charts to do that. Sorry, let me go through this data set and see how to achieve that task. I'm just doing this gradually the same way we are doing it. Hmm. I'm thinking probably we can extract uh we can extract months from this date column that we have here. Then we can move on from there. I'm thinking that is what should work out here. But however, let's continue. Let me create my this thing here. DF in brackets this sales amount. Mm, 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 mm. Sorry, I'm trying to brainstorm new to see how I would do this that I want to do. All right, let's try something. As usual, I've introduced AX to us. Big comma AS, and this has basically just create our chart um frame for us. And from here, fine. This has actually even suggested probably some stuff we may like to do. For example, bar chart for categories, what we can see here, like AS bar sales by category, which is what we have done. We have done here, dot index and sales category dot value. This is basically just showing that this sales category that we have by this side and this value is what it wants to plot for us. And we already have it here, category, sales, total sales that we have, and um, total sales by category as a title. So if we run this, we should be seeing a chart showing us that. All right, so the width is too much. I'm just going to reduce to 10. I think 10 is still too much. Let's do 5. All right, but that's not the problem we are trying to solve actually. Let's use 5 to 5. So this is to tell us the sales by category that we've calculated here. I think I need to extract months out of this transaction table. I really need to extract months out of this transaction table. So that I can continue with that analysis. All right, so let's do that. Sorry. Are you following me? Olawu, Samuel. I want to mention people that have not been talking. Daniel Igay. Are you following me? Please unmute and respond. Hello, guys. If you are following me, can you thumbs up so I can move on? Because there's no point in me talking.
We're following.
All right, thank you. There's no point me.
But
Yep.
the syntax for the bar chart, I couldn't get it. I think we're a bit fast.
Yeah, that's why that is the essence of you unmuting. Stop me. If it's just this is what we can do. You know you have learned it from this training. Like I said, I forced myself to this training. I'm not feeling fine actually. So there's no point me wasting my time if people are not listening. So any question, call me back. I'll gladly go back and answer. All right, so this is what we have done here before. We have already created this like, okay, sales by category. We said it should group by category and some sales. You can see this is the function here. Are you getting it? And from here, we say print sales by category. We can see it in form of a table, so to say, here, right? Now, below here, we now want to plot. Remember your AX plots now. You say AS, fig.as to declare the size of your plot. And we then move on to say AS, select the type of plot you want, which is bar that we choose here. And we now say sales by category dot index. Dot index. Dot index is just basically more like each of these category, we are using them as our index. We are using them as our index. Dot sales by category value. And it's taking this as a value here. This I can't analyze this column. This sales amount that we are seeing here is the one is taken as a value, while this group by the functions that you actually group by here, sales by category that you group by here, is taking it as index and which is all these things that we have here, the sales, this blah 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 that we have here, all this beauty, clothing, different category of our sales. It's taking them as our index, and yeah, as usual, you just declare your label, x-axis label, and y-axis label, and this title. So is this all this that we want to put and title, and when we do that, we run it, and this is what we have here. You could equally just be plot.show. We still have what we want. Dot show. We still have what we want. Do you get that?
Yes, sir.
Mhm. All right. So what we have at hand now is we are thinking of how to extract month and year from our data dates. So let's do this. DF, we are going to declare a new column called transaction let me just trans months. So we move on like this. This will only extract month for me. I know this. It will only extract month, but for those of you that you are an analyst, you know this will not solve your problem. In a situation whereby, let's say 2024 is gone, we are in 2025, and you want to look at sales by month, will you now be saying January 2024 and January 2025? You should add both of them together. No, it will not work, which is what I've been cracking my brain for since. So we can say use another function instead of using that. Let's say spring f time, open brackets, comma, quotes, y dash months, y and n. So what we are basically saying is that from this date column, bring out a string for me that will extract months dash, that will extract the year first dash the months. So I hope this work. Let's run this. I think we've created that now. Let's run our df again. Df dot add open brackets. Let's just see the first 6 column. I think we have it now. You can see 2023, this is extracted already. All right, so can we now do something by
And go back
plot?
to the, sorry, please.
All
Go
right,
back to the, yes, that transaction month, the code.
yeah, this is it.
Sorry, sir. Does that mean that the percentage Y, percentage M is year and month?
Yes, from the
Okay.
dates. If this has not been converted to a date, if this has not been converted to a date, this will not work. So this function you have here it works along with dates. Is that fine now?
Yes, sir.
All right, so let's move on. So for every other person, if you have any question, you can stop me at any point in time, and I will take time to explain myself. So
Okay,
let's,
I was
all right.
actually speaking. I don't know, I was muted. Okay, can we call the percentage like a white card?
Yes, more like can we say it's a white card, so to say. I mean, if you have used Excel before, Excel before, There are situations whereby you want to extract year months that you use test bracket open, maybe Y and hem or something, and it will just extract it for you. I think we are seeing similar thing. I think what we should be saying here is that if you put MM here, what do we get? Let's see. It's still the same month actually. So these are more analysis we can do actually to see that we can see the month in form of tests. To see that we can see the month in form of tests. These are some other analysis we can do. So this that we have here, we can say is similar to the test in your Excel that you are using. It is what it is. It's a function that gives you that. Do you have any other person that have anything, any challenge or any issue you need to
It's
trash?
giving me error.
This code,
Yes.
have you converted your tests, your transaction dates to date time?
Yes, I've done that.
If you have done it, you should not have error. If you have done it, you should not have error.
I don't know what I'm doing that's wrong. Dot T, PT, dot selector. Hmm.
So without wasting much time, this is it's more like a documentation, and I'll just challenge us. Let's go and research it. Let's research it. Like this one that we just talked about now. I checked the documentation and I discovered that if we use B, it will bring the full month for us, and which is what we have here. So what we'll just be doing now is that we would be plotting our
Excuse me,
sales.
sir.
Hmm. Which one
You
is this
said
again now?
you are
Sir,
seeing another.
is it only the capital B that can be used or any alphabet?
It has to be what you are seeing here. This thing you see here is syntax. You
Okay,
must follow the rule. If you don't follow the rule, it's not going to work.
okay.
All right, so let's move on to just see how we can plot this. Can we group by, let's say we group by our year transaction month now. Um, sales by month, sales by month, sales by month equals to DF. We can see now group by the month column and sales amount. Let's run. Okay, we need to print it. Print open brackets sales by month. You can see this is what we were able to get by month here. So we could just go ahead and be plotting this in form of charts and see what we would get out of it now, just like we did for this one. Fig AX. Can we just check what he has done for us? All right, sales by month, comma, value that we have here. And when we plot this in form of bar charts, you can see what we have done. Wow, this is telling us that some of our sales are negative value, and you agree with me that that's wrong. Some of our sales are in negative value, which is entirely wrong. All right, so let me change this to Y. I can see that all right, let me change this to M that we have before. The full month is to cover some on the charts. Wow. Do we need to expand it? What? I think we may need to use plot the show and see what we still have. They are clone like the stuff is too much, so they are kind of covering each other. So what do we do about that? Let's use this function called plot.trick. Sorry, plot.s column tricks rotation 45, which was the default we got before in that one. So with that, you can see it's just tricking it in like, okay, angle 45 degree. So they will not be together. All right, this is what we have. This is what we have here. For this, you can see the month and all that like this, going like that. There is another way to go about it. There is another way to go about it, even without extracting or group by this everything that we have here. We have another way to go about it, which is what I want us to check now. Another way to go about it is this. We can have our fig comma x equals to this that we have. No, I'm not going by this. I'm not going by this. I'm not going by this. I'm not going towards this direction. All right, so let's say we have our bar charts that way. We have our monthly underscore sales as index. We have our monthly underscore sales as index, and we have our what's this now? We have our monthly sales as value. This as index. What do we do? What do we do? What do we do? What do we do? All right, so let's move on. Seeing quite a number of error here. Color equals to, let's use sky blue. That needs to be in spring. Sky blue. Let's label it as sales. Equals to monthly sales. All right, so let me delete this. But I'm seeing this error. Let me close this. Let me just run and see what I'll get. Monthly sales index string type string. Something is wrong there. I'm thinking this is conflicting that. I'm thinking so. All right, let's take it like we've learned what we want to learn here. I'll just delete this. Or what do you think? I would I would still want you people to see this by the time I'm sharing this thing with us. Let's just run from beginning again. Run, 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 run. And let me just keep this there around. So run, check, everything is there, and syntax. Let's confirm. We don't have any non-value here. Let's confirm the data set. Your date is date. Okay. I just you don't even want to run all this goodbye, 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 goodbye. Now, let me jump here and run this.
So
Why
I
am
think
I
it's
getting
because
this wrong?
I think it's
Please
because we've
comment.
not defined. I think it's because we've not defined that monthly sales. We don't have anything like monthly underscore sales from the beginning.
Really?
Yes, I think what we've been using is it month underscore sales underscore by underscore month.
All
We
right.
don't have one to show monthly underscore sales.
We don't have any column showing
Or,
monthly underscore
or the
sales.
column you have trans months.
Let me just check what I have. I think I
Trans
printed
months.
it. I don't want to
Trans
use this
months.
transmont. I don't want to use this transmont.
The sales underscore amount we have, and then trans month. Thing.
All right, so let me do something like this. Transaction. Let me just go and see if I can copy it. It's not defined. Just give me some minutes. Let me look at where the error should be coming from. Okay, I think we need to, sorry, this is sales category. Where do I go by month the other time? Let me do this. This converts to spring. Do you know the reason why I am having issue with this? Let me just explain to you. Maybe everybody will understand me now. How many of us notice something wrong with this chart? Somebody should just point out what is wrong with this chart. I need a response.
The y-axis.
Not the y-axis. Fine. This is
Is
value
there
that we
from
have.
the negative?
This value that we have inside for the sales. We have negative value. That's why it's shooting downward. We would confirm that the x value, the x-axis, who can tell me anything wrong with it?
It's not sorted.
think
Is
we have-
that it?
God bless you.
Oh,
And that is
2022,
what is giving me headache. You can't present this to anybody and they will not lambast you that what are you doing with this. So let us create, I'm thinking we should create another sales month column. Let's see. This one we have is a spring. Is a spring. How many of us know what we mean by spring? Spring is more like A, B, C, D, E, F, G, H. You understand? And this thing is sorting it in form of alphabet. You imagine one comes first, two, three, four, five. Ordinarily, when you have situation like this in Power BI, you can then start becoming with indentation or something using your switch function and all that. But we are not going towards that direction in Python this evening. So what I think we should do now is let's have a new column called sales amount or sales months. You know, we call that one transaction month whatsoever, so I don't have problem with that. Let's say DF open brackets month. We want to create this new column. Instead of me using spring that I used the other time, I'll be using another function. This is transaction date, right? I will not be using month name. With this month name work, it will still be giving me what I don't want. So there is a function called date to period, date underscore to period, months. So this one will be giving me my value on monthly basis, So let's see it. Now let's check. We can run before we start doing all this, we can run our DF. And this thing I just showed you now, these are some of the things you need to put your eyes on anytime you're analyzing data, or else you can be flawed probably when you are presenting it. All right, let's check. We have the month now. You can see now this is more like date format, and this can sort properly. My thoughts, it should sort properly. So let's come here and do a group by. Let's come here and do a group by. Should we use group by 6 months now? Sales by month. Let's do sales by month. This time around, we are not using trust months. What's the name of that new column we just created? Months. Sales month here. This is sales by month. All right. This one it will still be printing the old one for me. So I need to put underscores here to give me the new one I just created. You can see now I have the new one that I've just created. So in this place, this thing here will now be sales. Let me just copy it. Let me just copy it directly. Sales by month. Sales by month dot index. And sales by month dot value, right? So let's run this. I hope it works. Error again. All right, so let's check where we have the error. It should actually work. There should be error somewhere. Okay, I have T in front of this my type here. I suspect that is the error. All right, so we have this here and we have it plotted like this. You can see that this one is in order. So two different functions. That is why I said it's good for us to always to read through documentation. When you have error like this, read through documentation. If you find yourself in interview, it's amount of documentation that you have absorbed over time that will help you. Interview, you will not be able to check documentation. But if you have done several work on and on here and there, in fact, it will surprise you. What they think they want to use to confuse in interview, that's what you have been playing with. All right, so you can see here, date to period, another function here, spring F time. This one converted to spring. Why that one converts date to period, like just dates by number, so to say. So it's not in test or something that it will not be able to sort properly. All right, I think another thing we can do here is on this our bar charts, can we just have something like let's create another AS for line charts. So that can serve as our trend. All right, it's still the same thing that we need, but the only thing we would be putting here is our line chart. Don't forget, if you are doing line chart, it will always be in plots. So you have it as plot here. And since it's a line chart, we'll be having some other things like marker equals, let's put 0, no, O, rather, letter O. Color, let's use red. Label, for the label, let's use trend. Is the name of the label of the chart that we want to do, trend. And line chart, also line style, let's use line style. Should not be styles, it should be style. Equals to colon dash dash, and this should be letter, small letter S, and I need a column here also, a comma rather, a comma. Let's see what we get. Isn't this cool? We have our chart here, our bar chart, and this is now pointing on each of them in form of trends. In form of trends. Any question?
Please let me see the code.
All right, so here's the code. Anybody with question? I want to make this better. Some about these things you see me trying. They are just like I'll just remember I've done something before. Let me try it again and see if it will work or something. And some of them I will just see that probably I've forgotten or something. But it's good. Let's just keep trying. I think we need to add legend. We need to add legend on our chart to know the one that is a trend. AI.legend. Fine. Let's run that. We see the legend mod trend. Yeah. Um. What else can we still have here? AX dot bar dot label month sales value should be what is there. Oh, it's not showing. All right, so let's do something again. Bars, comma, FNT equals, let me use what I used before. The what let me check. It's not giving me what I want. All right, we can actually research on that. Just let me tell you what I want. I wanted to create a label. I wanted to create a label that will be giving me the value on the top here. So that's what I wanted to do. So you can add that to your study, and we can so let's see if we can just do one more thing, because like I mentioned, I forced myself down here. Let's do something. There's a function called Seaborn imports, or a framework rather called Seaborn. It's also used for charts, and I have not mentioned it before. So let's import it and use it for this. So we'll just be trying to look at sales distribution by each of our payment method, sales distribution by each of our payment method, to see we call it bus plots. We see how they are. How will I even put it now? It's more of statistics, so to say, to see how they are dispersed from each other, to see the one that is more frequent, and all that. So we call it X-box plot, we'll be seeing the median, the interquartile range, outliers, those that were maybe value that are far from the mean and all that. So it's actually very good statistical tool that we use very well for analysis. All right, so let's just use that now. Plot.fig. Like those of you using Colab, it will always suggests. And the good thing is that Colab will follow the syntax 100% perfect. So it's now down for you to now look at it. Is it what I want? And for this case, what we want in our X value is not category. We want to look it on payment method. Payment method. Payment should be capital letter P. Payment underscore method, and indicate the y-axis. Here, you indicate the data frame that you are using. Don't forget, we are using DF as our data frame. And you can also add this to maybe if you want it to rotate or something. And lastly, let's have our plots.show. Can we run now and see? Shay, you can see now. How we have it there? Oh, the negative value, you can see all these ones, we call them outliers. They are far away from our data set. Ordinarily, you see this thing I showed you, sometimes we use it as data cleaning process to just see if we said we are done with our data cleaning and we feel it's okay. We want to see if we have outliers. All these ones, they have outliers, and it's really showing that this data, there's something wrong with it. There's something wrong with it. So what we can do basically is we need to remove those value that are equals to probably that are less than 0. We need to remove those values that are less than 0 and see how we can just clean the data. So these are some of the things we look at, but basically what this box plot does for us is it helps us to see our data out layers. Normally, assuming we don't have this 0 here, like all this one that is greater than that is less than 0 here, we should be saying, let's do something. Where do we have our DF, our last DF? Months, okay, months to period. Let's add another function here and says our sales, what is the column? Sales amount, Abi? Sales amount. We can say DF is equals to think rather than doing this, let me just use this. DF, this, our sales amount. Sorry, DF, open brackets. I want to add a condition, a conditional statement. Open brackets. Will this work for me? It's like I'm defining a new function inside my DF. DF equals to DF, open this, another DF now to pick my sales. Sorry, let me get this right. I don't mean this. DF should be like this. DF. We have someone at the lobby. Let me just accept the person. We have DF. What I want to do is that I want to create a condition that my DF should just pick my sales that is greater than 0. Any sales that is less than 0 is data error. So that's what I want to do. Okay, DF, open brackets, DF sales amount. This here, sales amount greater than 0. This is just the condition I want. I hope it works. Yes. So let me run this again. Sales amount that's greater than 0. Right? You can see we don't have anything less than 0 again. And let's run this. You can see. So this one is just like a median value here, and we all have outliers at value that are far above our mean here. That's what we're seeing at the top here. This toolbox is a very powerful statistical tool. Very, very powerful one. And
Please go back to the code.
you said the code?
Yes,
This is the code. All right. I think the first thing we need to do is
The
this.
DF, the DF.
Yeah. This is just like a condition that my sales amount must be greater than 0. I'll just do, let me see, do I share this data sets, business sales data set? Please check the WhatsApp. Do I share it with you? Business
Yes.
sales, all right. That's the last one I'll be doing. And we call it a boot camp. And hopefully we'll be coming up with another one that would deal with machine learning. So like I said, let's start with the difficult one. So the usual process is this. You can see this one also clumps in here. We can just use the same function we used there. This X tick twist by 45 degree. We can add it here also. And we have that sorted this way. So let's note that. The whole process starts from here. Import the data, check the data. There are no value. We see that there are no value. We first of all convert our sales data to numeric. So actually what we would have done here is for us, let's say is for us to use our D type to see if all these things are well converted to what we want them to be. And if not, we should do the right conversion and all that. And from there, we convert, we discover that this is not in numeric, we convert to numeric, and we will fill non-value to none to unknown for category. Anywhere you see NA or no value, change it to unknown for our category. For our payment method, we said, okay, use the most common one. So that's that. And our drop NA, we say that it should drop any column, any rows that our data, our customer ID is NA that doesn't have value. So from here, we also check, do we have duplicated value, like value that are the same across rows? We said we have 30. So we may be suspecting that this is possibly a duplicated data. So we dropped all these rows, 30 rows, And we also come down here to check again, and we move on here to eventually we came to check our data type and realize that this is not correct. Our transaction date is not correct. It should be in date function. So we come here, we use our pandas for this thing to convert to dates, which is what we have done here. And we then say that, okay, anywhere we have missing date, use the median. We could either use mode also, but just use the middle dates across all our data. And that covers all that. And we discover that we don't have any non-value again in our data set. So we move on to check our data type. We discover that it's okay now. And we start our analysis. Firstly, we check category. We group by category using our pandas here. And we then come to our matplots, this thing. So this one thing group by function that we've created there, we use the sales category as our index and the value. Obviously, it picks the sales amount as our value. Then we have our plot here that you can see in this place. So also we move on to convert our month to year, month and year, and we discover that this gives us in spring like in form of text. And when we did this, we plot, we discover that it's not in chronological order. So we move on to look for another function that we convert our dates to month, and they will still be sorted numerically as we really want to. We did this. We also say that, okay, we discover that we have some negative value for our sales, which is unusual. Obviously, some data must have been lost in this place also at the point of saying we only want data that are greater than 0 for sales. And we do this, we check, and from there, we go by again here, and we plot using the new months that we created, and we discover that this is in chronological order. We also plot another trend to show up here also. And we also ended by using our bursts plots, basically to check our movement or distance from our mean value here. All right, so that's that about that. Last thing I'll be taking us through, and we call it a day, is let's check this, our sales business data.
Sorry, sir. Please, this last one, that this box plot, you said is to check the movement from the mean.
Yes.
Right. I still don't get it.
Box plot is a statistical tool. What this does is that if you see this thing that we have here, it's giving us our main region. Are you getting me? And now looking for, probably we have outliers that deviate from the mean. And as you can see, we have one here far away from the mean. We have two of our data sets here also far away from the mean under this payment method. For this payment method, we have two, this we have two. For catch, we don't really have anyone that is far away from the mean. So that is what there are some very good case study that this would give you clearer picture. Probably the context we are using it for is not explaining it. You can research on it.
All right.
All right. So let's go to our sales, business sales data. All right. So let's read it. All right. So I will be using BF. Paul has explained this to us. It doesn't have to be DF. Read underscore CSV. Do we have the data set here? We don't. So let me drag it and put business sales data. Let me just copy it, copy parts, CSV. You notice that I didn't bother to import my pandas, right? Because it's there already. So I have this here now. The next thing we do is next line. Sorry, I want to use BF dot head. Or should we just use our DF? Let's use DF. So it will be easy across both. All right, so from here we can see the data we have here. We have marketing spent, the amount spent on marketing, customer traffic and distance rate and sales. So basically we want to look at what is the relationship between amount spent on marketing and sales, and probably check customer traffic also to sales and discount rates to sales to see the impact this has actually has on sales. So let's move on. Should we check for DF dot duplicate is none sum? Can we check no non-value? This data is clean. It's clean. But possibly we'll be having outliers, but however, I think maybe we can move on with this like this. Let's check another function that we may need to have here. Which other functions do we need to check here? Okay, it's always good to check df describe to have the general overview of the data itself. As you can see, this is our sales, this is our marketing spend and all that. This is our mean standard deviation for each of these parameters that we have. That's what this df.describe does for us. What other things do we need to find here? We check for non-value, and I think this is okay. So we can then move on to now start checking for what is the correlation between this, and I think we have done that before, but this time around we'll be using our Seaborn. So as usual, let's import Seaborn from this. Just want you people to know that that's what we are using. If import our Seaborn, the next function we'll be using is, we call it correlation matrix. So we use matrix that we have here, and we'll be having a plot of this relationship, this size. We'll also we'll be coupling up with CN heatmap. The last one we used was two box plots, but this one we want an heatmap, and we just, all these ones are just the color range and all that we have in here. And this is our title, and we are saying it should show it for us. So with this, we'll be seeing the correlation. This is the heat map now. This is the heat map that we have here now. As you can see, we have marketing. Marketing to marketing, the correlation will always be 1. Marketing, this one here to this one, it will always be 1. That is to tell us that there is correlation. But if you look at marketing spent, amount spent on marketing, customer traffic, you can see that there is positive correlation, but it's not a strong correlation. It's just like an 0.1. Correlation range from +1 to -1. when you have a +1 correlation, you are having a strong correlation, a strong positive correlation. -1 correlation shows that you are having a negative correlation, a strong negative correlation. So as this thing reduces down to a zero, both on plus or minus level, shows that the correlation is reducing and it's not strong enough. So this gives us a positive correlation. It's telling us that it's not a strong one actually, but in actual sense, once marketing spent increase, customer traffic increases. Discount rates and marketing spent, it's is not that correlated, but it's showing us a negative correlation that, let's say, probably as marketing spent increases, discount rate reduces. Fine, it could be another information to the organization, like, okay, should we spend more on our marketing and reduce our discount rates? Which of them will be beneficial to us? So these are some of the functions that we can actually get from correlation matrix. If you are to conduct, let's say, a machine learning model, correlation matrix is also very, very important. It's also very, very important, which I hope to touch in my distance. So this customer traffic to marketing spend shows positive correlation, checking them with each other to see how they are correlated. Any question? Do we
Can I
have
see
any
the code?
questions?
I want to check the code, sir.
Okay, the code is very simple. You remember the last class, we did correlation just for two variables. So this heatmap helps you to check multiple correlation, and multiple variables correlation, and that's what you are seeing here. You can check with this. However, most importantly is our sales. We can say, okay, marketing to my sales is positive correlation. My traffic, sorry, I want to get this right. Okay, yeah. Customer traffic to my sales, see the correlation. Discount to my sales, there's no correlation at all to that. And sales to sales will obviously be a strong correlation. So when you are looking at this data, you are not looking at this middle one because you are comparing the same value to the same value. So all this outside one is what you should be comparing with each other. Any question? All right. If you have done anything, let me know. Just share with us on the group. Anything that you have done, not necessarily this correlation, you can screenshot. Let me just see
All right,
those that
sir.
are following. Yep.
Okay, before you log out, that FMT, is it to make it two decimal places?
Yeah.
Is that the purpose?
Yes.
Okay. Okay.
Any questions from anybody? Ogochuku, I hope I've satisfied us using real life data today.
Yes, you have. Yes, you have.
Mm. So actually, it's the reality of you. It's very good for you guys requesting for that. Is you must understand the process. You don't just analyze data. Even for those of you using Power BI, it's very wrong for you to just get data. You don't clean the data, start using it. So That is one major powerful tool in Python. Major powerful tool in Python. It will give you all those things. All these things that you just see here that we bring out easily here. You may not be able to get it in other analysis too. But you can see checking on value easily. Where do we have it in my data? Fine. Power BI in your Power Query, you see some of all these things there also. So data cleaning is very, very, very important. Very, very, very. Somebody posted something on WhatsApp sometimes like a data analyst looking for a clean data to work with. It's just like the person waiting for eternity. You will not always see. You will not. Because most especially in the country we are, most organizations don't start with data. Most, like my current organization now, we a lot of cleaning, and you will not just say you are an analyst, you want to build new system, and that's what you do. What happens to the historicals? You need to get the historicals, merge it up together, then we can use. So on this note, we are calling it a boot camp, and can you just appreciate us for this boot camp? Maybe thumbs up or clap hands together. And please, I want us to drop whatever we've done today. Let's drop it on our WhatsApp group, as I will be sharing the code with us. So for the video, please just this week, usually end of the month is usually busy. End of the month stroke new days of the month is usually busy. So next week, Monday, which is next tomorrow, the 3 videos, 2 for last week and the 1 for today, I would post everything for us. All right, thank you, everybody. It's a great pleasure to have you. And without you, there won't be training. And we are glad that we've imparted you positively. So we are still going to keep the group, and we would mute everybody after today, because I will not mute everybody. I want you to drop whatever you have learned now, today, tomorrow. We are going to mute everybody. We have a group for SQL that we did last year. We are still going to come up with an SQL training. So our focus mainly wants to be on Python, SQL. So we are going to come up with another SQL training this year. And anyone that wants, we join that SQL group. We'll keep this Python group separate. So we are believing that we can keep on grooming people in all these 2 major skills, SQL and Python. I don't think I'll be going to Power BI. I don't think I'll be going there. So let's have a great time, and I wish to see our post on LinkedIn about what we have learned on the training. I will appreciate that, and tag me. Thank you, everybody.
Thank you, sir.
Thank you so much.
Yeah.